An interface defines what methods a class that implements the interface must define, but does not actually provide method definitions. Here we look at how to define an interface so that it can be implemented by a class.
An interface is similar to an abstract class, if you're familiar with abstract classes. You create an interface when you want to build a class hierarchy, but the superclass, or the main class that provides the basis for the hierarchy, is not a class that will normally or ever be instantiated. A good example, and the one I'm going to show you in this video, is a shape hierarchy. For example, circles, squares, rectangles, triangles, shapes. In that hierarchy, the superclass, sometimes also called the base class, or the class that is the root of the hierarchy, is a shape. But you don't instantiate a shape, you instantiate some type of shape. So it makes sense to build shape as an interface. And what an interface does is it has a list of methods. Any class that is going to implement the interface must define all of the methods specified in the interface. Now, the methods are not defined, just a name and parameters are given, and no fields or anything else. It's up to the class implementation to create a definition for each one of those methods. So let's look at an example. We're going to start a new project. We'll call this project ShapeLib. Now I'm going to put the interfaces and the implementations in the same file to start with, and we'll split them out later. So an interface is defined outside the main class for the project. And you do that by writing the keyword interface, followed by the name of the interface, in this case, shape. Next, we're going to define the list of methods that make up a shape. And this doesn't have to be the last version. We can add more methods as we think of them if we need to. So let's start off with, for example, we need to use the access modifier first. A draw method, because we're going to want to draw a particular shape. We might also provide a move to method with X and Y coordinates, like so. Then we might also want to compute the area and the volume, so we'll provide those methods as well. Oops, let's spell volume correctly. There we go. And that's it. So now that we've defined the shape interface, we can create classes and implement this interface. And by implementation, I mean they define all of the methods that are listed in the interface, as well as other methods if they need them. But for the class to compile correctly, it must implement at least this minimum number of methods.